Hello, ERA users. I'm happy to announce that today we are releasing ERA 4, which has been a long time coming. There's many new features within ERA 4 that users should be aware of. This is just a brief video to highlight what some of those main changes are. We've got a more comprehensive video that will be posted in the link in the descriptions of this video. Three major things that you should be aware of in ERA 4. We now have a circulating temperature and static temperature borehole model, and that is used to adjust our fluid density and fluid rheology due to downhole conditions, which gives us more accurate hydraulic predictions. We also use that temperature profile to adjust tubular metallurgical properties, both the minimum yield strength and Young's modulus. With the temperature model, we also have a new hydraulics package. The new package uses Herschel-Buckley, which is a standard industry method for predicting hydraulics in drilling operations, which gives us a more accurate prediction over a range of different fluids. We also characterize our drilling fluids and our cementing fluids differently, meaning that we define the base oil, brine, and solids phase of each of our fluids. We automatically adjust for downhole density and downhole rheology. And with that, we also now have a more advanced hydraulic lift algorithm that couples hydraulic friction to our torque and drag computations, which is important for floated and tight clearance casing runs. Now, it is on by default, so it is applicable for all operations, but where you'll notice it most is on those casing runs. Real briefly, I'll show you where you access some of these features. Within the Earth Builder, there's now a tab called Temperature, which is where we can define the geothermal gradient. We've got 5 different options for defining the geothermal gradient, just a standard straight line, an offshore model, a permafrost model for Arctic conditions, and then profile just means that you can input the temperature profile in a very flexible way. If you happen to know what the temperature is at different depths, you can just copy and paste. Likewise, we've got a model that defines the inlet temperature of the fluid as it enters the pumps, which can be defined 3 different ways. Heat retention, meaning just how much heat that is in the fluid as it comes out of the flow line is retained before it goes back downhole. A fixed temperature input, and a just direct offset, inlet minus flow line, just how much warmer or cooler does the mud get when it leaves the flow line and goes to the suction pit. If I close the Earth Builder and navigate to one of our hole sections, the drilling calculation, the drilling sub-op calculation screen doesn't look too different other than the fact that we've got the ability to define our temperature either in a static or circulating state. You'll notice a new plot called temperature, and the curves on the temperature plot will show the temperature at the bit, the temperature at the flow line, and then the gold vertical line represents the geothermal temperature. When I open the fluid dialog, this replaces what used to be called rheology, and the fluid dialog now allows us to define our Herschel-Buckley parameters, or the Herschel-Buckley parameters will be back calculated from our 6 fan readings. We also have inputs for fluid composition, meaning what is the brine phase, the oil phase, the solids phase. If it is oil-based mud, we define the oil-water ratio here as well. If we're using a water-based mud, then the oil-water ratio is 0. We've got a more expansive library of different fluids that come pre-populated with different brines and base oils, although you can modify and adjust any of these as you choose from the drop-down lists that are provided. Each of these library entries also includes an HTHP matrix, which defines the fluid rheology under combined temperature and pressure. And this data cube can be viewed and manipulated to get a better understanding of what the fluid does under downhole conditions. You can also paste your own HTHP rheology tests if you happen to have that. And lastly, in the fluid dialog, we've got some calibration factors that allow us to fine-tune the temperature model and the hydraulics model. Other output that is of interest in snapshot mode, you will notice that we now have a plot of temperature when the bit is at a particular depth. We have a plot of downhole rheology. Solid curves represent rheology inside the drill pipe. Dotted curves represent the rheology in the annulus. And that nomenclature is consistent also with our temperature and our flow regime plots. Flow regime gives us an idea of whether or not we're in laminar turbulent flow. And you'll notice that all of those calculations, those plots, are updated depending on bit depth. So we recompute temperature and we recompute rheology and, of course, hydraulics depending on where we're at in the well. In tripping mode, you will notice now that we are sensitive to things like flow rate and run speed. If I focus your attention here on hook load, when I run the string at a slower speed, that does have an impact on torque and drag, fairly minor in this case because it's just a drill string, but also flow rate. When I'm pumping, that has an impact because of this hydraulic lift phenomenon that we've talked about. Now, the hydraulic lift phenomenon can be turned on and off from the settings menu. If we click on settings, you'll notice hydraulic lift on by default, but I can always turn it off if I want to see the effects. Likewise with my metallurgical corrections. That's just a brief overview of some of the changes. There is a more extensive video that explains all of this in more detail, but I just wanted to give you a quick overview of what's new. As always, please give us any feedback, changes, things you like, things you don't like. You can contact me at bfoster2@kmtechnology.com.